Hello, viewer. We have got this question here, given that x equals 1 minus sine 2 theta and y equals 1 plus cos 2 theta. We are supposed to find dy dx. Hence, dy dx when theta equals pi over 6. In part B, the second derivative of the dy dx we got in part A. So here is the solution. From x equals 1 minus sine 2 theta. Okay, we get our dx d theta will be equal to derivative of the right hand side, that is 1 minus sine 2 theta. So dx d theta will be equal to differentiating constant, we get 0. Differentiating 2 theta with respect to theta, we get 2. Differentiating sine, we get cos. So it will be 2 cos 2 theta. So what does it mean? That our dx d theta equals negative 2 cos 2 theta. Okay, then from y equals 1 plus cos 2 theta, okay, differentiating y with respect to theta. Differentiating y with respect to theta will be equal to differentiating the right hand side, that is 1 plus cos 2 theta. So our dy d theta equals differentiating constant, we get 0, then plus sign, differentiating 2 theta, we get 2 times, differentiating sine, we get negative sine 2 theta, negative sine 2 theta. So this gives us dy d theta to be equal to dy d theta to be equal to, this will be negative 2 sine 2 theta. So we have the value of dx d theta equals negative 2 cos theta, and here we have dy d theta, which equals negative 2 sine theta. So what is next? Okay, next is to get, we are still in A, part A. Next is to get dy dx. This one equals dy d theta, I would say times, I don't know whether it's possible mathematically, yes it is, times d theta dx. Okay, I know where the problem is. The x. Okay, where dy d theta, equals negative 2 sine 2 theta, and dx d theta, this one equals negative, we got 2 cos 2 theta. So what does it mean? It means that the theta dx is the reciprocal of this negative 2 negative 2 cos 2 theta. So therefore our dy dx will be equal to dy d theta, which is negative 2 sine 2 theta times 1 negative 2 cos 2 theta, which gives us sine 2 theta over cos 2 theta, which is equal to tan 2 theta. So the first answer for our question, that is the y dx, this one equals tan 2 theta. Okay, that's the answer for part A. And for part B, to find the second derivative, that is d squared y over dx squared, this is the same as differentiating dy dx with respect to x again. So what does this one mean? We got our, from A, we got our dy dx to be equal to tan 2 theta. So this implies that our d squared y over d squared x will be equal to derivative with respect to x of what? Of tan 2 theta. Of tan 2 theta. Okay, so what do we get here? Differentiating this one, look here. We're differentiating with respect to x, yet here we have theta. So what does it mean? That the final expression of d theta dx will remain in the expression on the right hand side. So here's what I mean. Differentiating tan 2 theta, let's first differentiate 2 theta. What do we get? We get 2, dot means multiplication. Differentiating tan, this is sec squared, then 2 theta, then the theta dx. That's what we get on our right hand side. But do you remember what is the theta dx? From part A, the theta dx equals 1 over negative 2 cos 2 theta. Okay, if you can recollect from the previous part, so this is what you got. So therefore, d squared dy over dx squared will be equal to 2 and 2, this is 2 sec squared 2 theta dot, where there is d theta dx, we put 1 over negative 2 cos 2 theta. Okay, this gives us 2 and 2 will cancel out. So we shall have sec squared 2 theta over negative cos 2 theta. Remember, 1 over cos theta is the same as sec. So this is the same as writing sec squared 2 theta times sec 2 theta. So according to the rules of exponents, we simply add the powers. Here is power 1, here is power 2. Remember, there is negative sign, so let's put a negative sign there. So this gives us sec now to be power 3, then 2 theta. But don't forget to put